Let's do another related rates with expanding or shrinking a square. This time we have the sides of a square shrink at a rate of 2 meters per second. What is the rate of change in the area when the sides are 20 meters long? So again, we're relating side length of a square to the area of a square. So we are going to write our same equation where area is usually length times width, but since it's a side of a square, length and width have to be the same. So we have area is going to be the side squared. Side times side length. Since we know the equation and we're looking at related rates, we can just jump right into taking the derivative. And the nice part is this section doesn't have super crazy derivatives. There's not like quotient rules all over the place. We have first the derivative of 1a with respect to time. Derivative of 1a with respect to time would just be 1 dA dt, how the area is changing with respect to time. And the derivative of s squared with respect to time would just be 2s ds dt. So some fast, simple derivatives. Just remember your d something dt. Like if you're taking the derivative of r cubed, you'd have 3r squared dr dt. If you're taking the derivative of p to the fifth, 5p to the fourth dp dt. Everything has a d something dt. And now we're gonna actually have to think about what's going on in this problem. We start out with area compared to side length. And since we took the derivative, we got how the area was changing with respect to time and how the side length was changing with respect to time. We're always going to be given one of the derivatives and solving for the other. We're going to be given one rate and solving for the other rate, and that's why it's called related rates. So we're going to go piece by piece and try to figure out where each of these numbers go. So we have the sides of a square shrink. So we want to make sure we're decreasing, not increasing this time, at a rate of 2 meters per second. Well, this is the sides. So this is going to be the rate at which the sides are changing. So we want to figure out, is that s or ds dt? Well, it's the rate at which they're shrinking, so it must be a rate of change. It's ds dt, 2 meters per second, which you can also tell it's a rate just given that it has multiple units. So 2 meters per second compared to like if it was just 5 meters and not a rate of change. Rates of change or derivatives have 2 units. It says, what is the rate of change in the area? So we're solving for dA dt. How fast is that changing when the sides are 20 meters long? So S, the current side length, is 20 meters. We're solving for how fast the area is changing. So we are missing a variable. We could plug in to this original equation. Anytime you're missing a variable, we could figure out what the area is when the side lengths are 20 meters. We could do 20 times 20 and see that the area was 400. We're not asked for that, so I'm not even going to find it. I'm going to go ahead and plug in for each piece. So I have 1 dA dt. 1 times anything is just going to stay itself. We're solving for dA dt. We're going to leave that as dA dt. We have 2 times the current side length. Well, the current side length is 20 meters. And how fast the side length is changing is by 2 meters per second. So if we multiply these numbers together, there is a mistake here, which we're going to multiply these numbers together and we're going to talk about it. So we have 2 times 20 times 2. So we're going to get 80. And we have meters times meters, so we're going to get meters squared per second, right? The area would have been in meters squared, and how fast the area changes is in meters squared per second. Well, let's think about interpreting this problem. So we were given as the sides shrink by 2 meters per second, the area is going to do what? Well, we got a positive answer, which would mean as the side lengths were decreasing or shrinking, the area was increasing. So we must have made a mistake here, right? If you make the side lengths smaller on a square, the area is supposed to get smaller. So we should have gotten a negative answer. So let's go back and look at the setup. The sides shrink. As soon as you see a word indicating decreasing, you want to make sure you make that rate negative. ds dt should have been -2 It was 20 meters, but it's decreasing by 2 meters per second. So our overall answer, 2 times 20 times -2, should be -80. So just be super careful. Otherwise, you might get to the end and do the interpretation and be like, that doesn't make any sense at all. But as the side lengths shrink, now that I put that -2 in there, the side lengths are decreasing by 2 meters per second. The overall area is also decreasing, which makes more sense. So as the side lengths shrink or decrease by 2 meters per second, the area also shrinks, or you can write decreases by 80 meters squared per second. So that makes more sense. When our square got bigger, our area was getting bigger, and as our square side lengths got smaller, the area got smaller. We should have gotten a negative dSdt, which gave us a negative dAdt.